Okay, so I'm just going to do this problem out for you. We're given that f is a function that satisfies this property. F prime of x is equal to negative 3x times f of x for all real numbers x. F of 1 is 4, and this limit, the limit is as x goes to 0, x goes to infinity of f of x is 0. We have to evaluate this improper integral in part A. Okay, so this integral so we note right away that I have another name for this, which would be more helpful, and that name is f prime. And that's helpful because the antiderivative of a derivative is the function itself. All right, and at this point, let's do proper notation. So we're going to turn this into a definite integral, because right now it's not. It's an improper integral by making this change. Okay, but look, the antiderivative of f prime is f. So this will be straightforward here. So this is going to be the antiderivative of f prime is f, evaluated from 1 to b. Okay, and that's the limit as b goes to infinity of, by the fundamental theorem, f of b minus f of 1. Okay, and limits work almost like you can distribute the limit. You can do the limit of the first part minus the limit of the second part. Okay, but they told us that f of 1 up here is 4, so I know that's a 4. And then they told us that the limit as x goes to infinity of f of x is 0. The variable is b, but that doesn't make any difference. The limit of a number, the limit as this number goes to infinity of f of that number still is 0. So we now know that this is going to be 0 minus minus this. The limit of a constant, of course, is the constant itself. Okay, so there's part A. Part B says to use the Euler's method starting at x equals 1 with a step size of 0.5 to approximate f of 2. Okay, so the way I would recommend doing this, in spite of what maybe the answer key says, is I'd like to make a nice little table. It's useful to organize. Okay, our step size is 0.5, they say. So note that means that delta x is 0.5. I'm starting at the point I'm given, which is 1, 4. I'm approximating f of 2. So I go up by my step size until I get there, and our final answer will end up in that spot. And how do I find dy dx? Well, they're telling us that f prime, which is dy dx, different notation, is negative 3x times f of x. So we know that we need this. Okay, we're going to need that to update. So right away, I've got dy. So what is dy dx when x is 1? Well, it's f prime of 1. So that's negative 3 times 1 times f of 1, which is negative 3 times, so f of 1 is 4, so it's negative 12. Okay, and so now my change in y is going to be negative 12 times my change in x, which is negative 6. I add that, right? It's a change, so I add that to my old y value to give me a negative 2. Let's make this red, and then I continue, or I do it again. So now I need f prime of 1.5. So that's going to be negative 3 times 1.5. Right? Again, I'm just using 1.5 comma negative 2 as my info, times f of 1.5. Okay, now f of 1.5, we just use f of 1.5 is negative 2 here. Okay, so this is negative 3 times 1.5 times negative 2. which gives you 6 times 1.5, which is, so it's 6 times 1.5 is 9. Okay, so now this is 9 times 0.5, which is 4.5. I add that to end up with my final answer, which is -2, so it's 2.5. -2 plus 4.5. Okay. Okay, and so now part C, write an expression for y equals f of x by solving the differential equation dy dx equals -3xy with the initial condition f of 1 equals 4. I don't know, if you've looked at the answer key, you should know this is, what we're about to do is 5 points, right? So A and B were 4 points, this is 5 points. So you can tell solving a differential equation like this is important, at least to the College Board. So dy dx equals -3xy, okay, and the initial condition is f of 1 is 4. So let's write that. So we got to use separation of variables. That alone gets you a point. So separation of variables looks like this. Okay, and now we anti-differentiate. Let's do the right side first. This becomes -3/2 x squared plus a constant. The antiderivative of 1 over y, so it's the natural log. We're supposed to say the absolute value of y. Your y coordinate's positive here, so if you note that, you can ignore the absolute value. Okay, and now now we just got to solve. Again, we're gonna need our initial condition to get our particular solution, but right now we can get our general solution. So this will tell us that y is equal to e to the -3/2 x squared plus c. That's all in the exponent. As I've mentioned many times, the convention here is to replace this new number here with a different letter, like y or like a. I usually use a. Okay. So now your general solution to this differential equation can be expressed like this. Okay, that, remember, just for note terminology, that's the general solution. Okay, but we want a particular solution because that's what they told us to find. So to find our particular solution, now we got to use our initial condition. Okay, so I know that y is supposed to be 4 when x is 1. So this tells me that 4 is equal to a times e to the -3/2. In other words, 4 times e to the 3/2 is equal to a. Again, you can, right, if you multiply both sides by this, remember the way exponents work, this becomes a 1 now, because exponents add, comes e to the 0. So there's our a value, and now I've got my my particular solution. So my particular solution, the one that I would circle, is y equals 4e to the 3/2 times e to the -3/2 x squared. Okay, and that's fine. I guess so that's fine. If you wanted to rewrite it by combining exponents, you could, but you know, this is fine. Or you could say -4e to the there's nothing wrong with what I wrote above, but if you add exponents, it would look like that. All right, so that was like full 5 points. You can kind of see there's a lot of places that are worth points. So hopefully this helps you understand this problem.